Alright, so dealing with the second method using a parallel representative rectangle. What is the difference? The difference is the formula for moment of inertia, which is mass times distance from the reference axis. What is the reference axis? It's x. So from the x axis, the distance is y, so that becomes y squared. Now what is mass? Mass is density times volume, P times delta Vx. What is volume? Volume, remember now, because it is parallel, it will be shell method. So the shell method is circumference times height times thickness. You're rotating around the x-axis, so your radius is measured in terms of y. 2 pi r, so your radius is y. The height is the longer side. The length of this rectangle is the height, which is x2 minus x1, and the thickness is delta y. So we transfer here. So there's the formula here, and multiply now by y squared. Multiplied by y squared. Alright, so now, so that's going to be 2 pi p, and then we have d and c there. Y times y squared is y to the power 3, and that's x2 minus x1, and that is dy. So now, that's going to be 2 pi p, d and c is the square root of 27, 0. We got y to the power 3. We need to integrate with respect to y. So we need x2 in terms of y. So we make x2 the subject of the formula. Right, you take your equation, make x2 the subject of the formula, which is 2 over 3 times the square root of 9 plus y squared. That is just x2 minus, sorry, that is x2 is 4, my mistake there. My mistake, x2 is 4. So it's going to be 4 minus 2 over 3 times the square root of 9 plus y squared. So x2 minus x1. So it's 4 minus x1, which is what we have there. Now we have to separate this. Separate them into two different problems. So that's 2 pi p. The integral here, square root 27 and 0. Then I have 4y cubed dy. Okay, that's 4 times y cubed is 4y cubed. Now, dealing with the next term there, that's going to be plus, we have 2 pi p square root 27 and 0, and then we have our minus 2 over 3 times y cubed times the square root of 9 plus y squared dy. So I'm removing the brackets. Y cubed times 4, there's it there. Y cubed times minus 2 over 3. We've got our y cubed times minus 2 over 3 there. We've got our 2 pi. You can see that? Alright, so where is the problem? It's this one. This is easy to integrate. The problem is, so we need to use a bit of a U-substitution. This is not a straightforward exact derivative example. Alright, so because you can see it's just a U-substitution. Let's use a U-substitution. Let u equal to 9 plus y squared du over dy. The derivative of 9 is 0. Derivative of y squared is 2y. So then dy is equal to du all divided by 2y. Clear with that? So I'm using a U-substitution here. This is a special case example. So that becomes minus 4 pi over 3. P, that's my, forget about the limits for now. So this is a y to the power 3. This is the square root of 9 plus y squared, which is now u, and dy is du over 2y. So y will cancel with y cubed, with y, one of the y's there. So that becomes minus 4 over 3 pi p y squared times square root u du. We got a problem with the y squared. I told you this is a special case example. So there's y squared here. What is y squared equal to? U minus 9. Right, y squared is equal to u minus 9. This is like N5, special case examples, which is required here now if you're doing this. So that's minus 4 over 3 pi p. Simplify, that's 1 plus half is 3 over 2 minus 9u to the power half. Remove the brackets. Exponent clause, 1 plus half, 3 over 2. And this is du. Now, let's integrate. So that becomes minus 4 over 3 pi p. Integrating here. Integrate u to the power 3 over 2. That's going to be 5 over 2 divided by 5 over 2, which is the same as 2 over 5. Half plus 1 is 3 over 2. Okay, let me leave this as 3 over 2. Now, what we're going to do here is, are we going to substitute back for u? What was u? 9 plus y squared. You can do that if you want to. Or you can just change the limits. Okay, now you see the work that we did in N5, but we did it briefly, changing the limits. It's useful here now for these complicated problems. So let's change the limits here. So instead of substituting back for u, let's just substitute straight into u. What do I mean? I know that u is equal to 9 plus y squared. So what is the upper limit? Square root 27. So if y is equal to square root of 27, if I put square root of 27 here and square it, what will it be? 27 plus 9, 36. Right? When y is equal to 0. If y is equal to 0, what is u equal to? U is equal to 9, because it's 9 plus y squared. Yeah? So therefore, this is a 36 and a 9 here. So what we're going to do is we will work this one out. This one here, 2 okay, that will be 2 pi p. That's going to be 4y to the power 4 over 4. Here it's a straightforward substitution. Square root 27, 0. We're going to work this one out. Or you can work this one out while I'm working this one out. Alright, so let's see what we have. 2 over 5. Some of you work this one out here. There's it. Let me work this one. So that's 2 over 5. X to the power 5 over 2. Alright, now let's see what we get when we substitute 36. Getting 1814, comma 4. Substituting 9, I get minus 64, comma 8. add it up, I'm getting 1879.2 multiplied by -4/3 times pi, which is equal to, this is -7,871.574,553. That's what I'm getting here. Just double check me on this side. Yeah, I'm getting 729 times 2 pi is 4,580,4,2089p, and that's there. Just double check the calculator work there. Now, alright, so there was an error. Thanks to my student who corrected me. My mistake was the 2 here, I forgot to divide by the 2 here. Okay. So then here, 4 divided by 2 then is the 2. So that carried over here. So therefore, and also the calculator work. Okay, now I'm changing the limits. If you don't want to, you can always substitute back. But when you substitute 36, this is what you get. And when you substitute 9, that's what you get. Multiply, and this is what we get now. Alright, so now, let me make sure about this one. So this is 729 times the 2 pi there, which is equal to 1458 pi p. Let me just leave it in terms of pi because it's not my final answer. Okay, so now we need to add these two up. That and that together, because we separated them because there were 2 different integration problems. Now let's add them up. So therefore it's 1, sorry, let's write that down again, 1458 pi p minus 3935.787p and finally we get the correct answer now, which is 644.655p. Yeah, this one seems a bit complicated, but it can be done, and this is it. So this is using a parallel representative rectangle. So what is the difference? The difference is distance from the reference axis. So that's a formula, that's a difference in the formula. Also, because you are using the parallel representative rectangle shell method, but in the exam, for this specific example, you will not want to do it. It takes too long to do it this way, yeah? But it's up to you. Right.